Download this code and get free GPT-4o from codegive.com, link in the description below. Sure. In this tutorial, we'll explore how to integrate an array using numpy, a powerful library for numerical computing in Python. We'll focus on the numpy.trapz function, which performs numerical integration using the trapezoidal rule, and the numpy.simps function, which uses Simpson's rule for integration. ####. What is numerical integration? Numerical integration is a technique to compute the integral of a function when an analytical solution is difficult or impossible to obtain. The trapezoidal rule and Simpson's rule are common methods used for this purpose. ####. Prerequisites. Make sure you have numpy installed in your Python environment. You can install it using pip if you haven't done so. ####. Using numpy.trapz. The numpy.trapz function computes the definite integral of an array using the trapezoidal rule. Here's the basic syntax. Y, the array of values to integrate. X, the sample points corresponding to y. If not provided, it is assumed to be evenly spaced. Dx, the spacing between points if x is not provided. Axis, the axis along which to integrate. #####. Example of using numpy.trapz. ####. Using numpy.simps. The numpy.simps function computes the definite integral of an array using Simpson's rule, which is more accurate than the trapezoidal rule for many functions. Here's the basic syntax. The parameters are similar to those of numpy.trapz. #####. Example of using numpy.simps. ####. In this tutorial, we learned how to use numpy to perform numerical integration of an array using both the trapezoidal rule, numpy.trapz, and Simpson's rule, numpy.simps. The trapezoidal rule is simpler but less accurate for certain functions. Simpson's rule generally provides better accuracy for smooth functions. Feel free to experiment with different functions and intervals to see how the integration results compare.